Hi guys, Andrea Ciani here for the fifth type of wire netting tutorial about geometry nodes and Blender. Let's get started. I am in Blender version 3.3.0 and we can go up to the plus, general and geometry nodes. Shift A to add a mesh, plane is a good result, and we can select this, click new to create a new geometry modifier, and concept. The concept is create a line, then transform this line in this shape, then create multi-instance of this shape to create this particular shape, then apply to this shape one piece of object and make few tweaks to get a brilliant result. We can hide the annotation and let's create the curve line. We need to create a simple line curve. Press 3 to see the right orthographic view. We need to resample this curve. We can start with 128. I suggest you to use a multiplied value of 2 when you resample curve, because this is easy. Decrease the resolution always with an integer number. So if you start with 2 or 4, 8, 16, etc., you can easily increase or decrease the number, always getting an integer number. So this is 128, so you can easily divide by 2 and then divide by 2 and so on until the 2 value. So set 128 for now. We have to set the type, spline type, to Bezier to have a smooth result for these lines, and set the handle type. It's absolutely important, this. Now we have to set position. We have to change the position of these points to get a sine shape. Set position. We could get the index of each point, but it's not correct because we will have to change this resolution with a dynamic number of count, and so we want to have the same shape even I change the resample curve. So I don't want this node, I want to use the spline parameter, and exactly I want to use the length and not the factor. So I can use this, go to sine, we have to use a combine XYZ. We want to change the position on the y-axis. You can see this green axis. We can use the y-axis and link this to the offset. So this sucks, obviously. We can increase the frequency of this shape. To increase the frequency, we have to add a math operation to multiply this length with a number, and you can see the correct frequency. So we can multiply this with pi multiplied by 2 to get for one height, so one value of this height, one entire period of this shape, and we can multiply this by a custom value to increase the frequency, and we can export this information. At the same time, we can export the length of this curve line, so we can use a combine XYZ, link this vector to the end of this line, and export the z-axis. So we can go to group and rename it in height from 0, and we can export this value as the frequency that we want. So if I set one frequency, I get one period. It's obvious. Now, because we will have a piece of an object here in the contact between two shapes, we have to shift this shape to be able to add the first piece in this point. So we have to shift a little bit this value input of the sine by what? By this period divided by 4. So this piece, so we want this value here. So if I add a math node here, set 0, you can see if I change this value, I can shift the shape where I want, and this is the value 1.610, but we have to set pi divided by 2 to get this perfect point. Now, another thing that we want is to have an amplitude of this shape, so we have to add half after the sign, we already have the output value of the sign. We have to multiply this value by a value, so we can increase or decrease the amplitude of this output result, and we can export this value as an amplitude from 0. The frequency is 1 for main value, and the last thing of this shape, we have to change proportionally the count of this resample curve, because if I increase this frequency a lot, you can see this weird effect, because we have few points for this frequency value, so we have to adjust this count with a relationship with the frequency. So to do this, I need to snap the height of this value, so I don't want this result, so I need to have a snap value with an increment, but the increment, because we have a frequency, so a number of shape, we need to divide 1 by this frequency to get the correct length of this height, to get the correct increment value of this snapping tool, because the height is a linear value, so we need to add a math value, a math node, use a divide, so 1 divided by the frequency, we get the correct increment value for this snapping, and use this for the z-axis. So now if I set 2, you can see this particular effect, and we can use this snapping value, adding the basic default value of 128 to have the proportional changing of the count when the height and the frequency increase. So we can set these. Now if I increase the frequency a lot, we have the similar result of before, but we need to use a little value of this amplitude for our tutorial for the final result. So if you have this amplitude value, you can see the frequency gives us a perfect shape without wrong values, and with a small value of a count if the frequency is a small value or the height is a small value. Now that we have this curve line, we can select all these nodes, Ctrl J, F2, and rename it in a single curve. Save the project. Now we have to instance this line to an horizontal line on the y-axis, so we can create a curve line here, resample this curve, Alt right button drag. We have to select length. We have to use the length because we have this radius, and this radius is not an integer number but a float number, so we have to use this distance to get the correct resample length value. So as always, we can use a group input to export what? The combined XYZ value of the y-axis. So we can use this, select this, go up and set width from 0, set this to 1 for example, 1 for the height. We can increase a little bit the amplitude so we can see better the result. And now we have to instance on point what? On this point we have to instance the previous curve line and export this to the output, but we have to set the correct value of this length. Now for the final result we will use a profile curve, so we can simulate this effect, so we can use a curve to mesh. We will move these nodes to the end of this entire environment, but we will use now these to export the correct radius. We have to add a circle curve. We can link these, fill caps, decrease the radius, perfect. We can export this radius value, this is so important, from 0 is perfect. And now we need to rotate this instance with an alternate index, so we can use the index of the point of this horizontal line, link this to the module, and each two line multiply this value with 180 degrees, convert this to radians because we will use a combine xyz and not directly the rotation vector of this instance on point, we have to use the z-axis and link this to the rotation. And now we have the mirror of this shape. So you can see this is an error. There is an error here because we have to adjust this length value, but we know that we want to shift the axis of the atomic shape with a value. What value? We know this. We have the first axis here, we have the big radius, we have a big radius here, and so this is 2 times the big, and we have here 2 times the little radius and 2 little radius. So to get the correct length of the resample, we have this total distance. To get this number, we have to get the amplitude multiplied by 2, adding what? A multiply by 2 of the radius of the single wire. And we can use these for the length. Save the project. Now you can see, I hide for a moment this annotation, that if we decrease the width, we have this little issue. I don't know why Blender makes this effect, but to avoid this behavior, we need to snap the horizontal value of the width, snapping this by what value? The value that we used for the length value of the resample curve. So in this case, I can use this effect and we can see there's no more issue if I increase or decrease this number of width because we have a snap value. Now let's make the layout better. Perfect. I remember you that we will move these nodes to the end of the entire environment. So to get an easy result while creating this environment, I will leave these for a moment. Select all the nodes, Ctrl J, F2, all instance curve. Now it's time to create the single piece of the geometry. For this piece, we will use a geometry from scratch, and this will be the shape. So half an arc, another arc, and a rectangular shape, deleting these edges, make these all together, then we will extrude these to the Z, exporting the correct parameter that we want with a relationship between this radius and the radius of the single wire profile curve. So first of all, we can insert another group input. We can use an arc curve parameter, Shift Ctrl click, Shift Alt and click to see this arc. We can use a little radius. We need to use only 180 degrees. We can invert this piece and we have to translate in this direction this arc. So we need to add a transform node. It's obvious, a combine XYZ value. Link this to the translation. We need to add a math value to multiply the input by -1 because we want to translate this value by a negative number. So the next arc will be moved in the y-axis by a positive number. So we can link these together and we can use a new input value that we can export and rename in clip width from 0. We can select this node, Shift D to create the other arc that we want, Shift drag right button to link these to the Y of the other arc, deselecting this invert arc because we want this arc in this direction, and we can join together with the Shift Ctrl right button and drag, and we have the arcs, so we can decrease or increase this clip width as we want. Save the project. Now for the radius, we can use a relationship between the radius of the wires. So if I decrease this value and if we have a wire here and a wire here with their radius, we can use this radius multiplied by 2 to get the correct radius of the clip, avoiding a collision between the wires and the clip corner. So to do this, we can easily multiply the radius by 2 and use this for the radius of our arc. The same approach with the radius of the other arc. We can use this creation of the node with shift right button drag, G to move here, G to move, and we can create a better layout. Now we can select these nodes, Ctrl J, F2, left clip part, and select these nodes, Ctrl J, F2, right clip part. Now we need to create the middle part of this arc, so we can decrease a little bit these pieces, and we can use a simple grid primitive with two vertices and two vertices here, and we know that this size is the radius multiplied by 2, and this width is a number that we want in general, so the clip width, for example. Keep in mind that the width clip will be the distance between the center of the radius, so this point and this point, not the entire clipping. For personal choice, I chose this solution, but you can manipulate this layout after the tutorial if you want to adapt this clip width between this point and this point if you want. So we can easily link the radius multiplied by 2 in the x-axis, link this grid to the join. So you can see there is an issue here because we needed to multiply by 2 another time this radius, because this radius here is the radius of the wire. So this radius of the wire multiplied by 2 gives us the radius of this arc, but we have to multiply by 2 to get the entire length we want. So we need to add a math node here in the middle, multiplied these by 2, and voila. Now it's time to adjust the y value, so I can decrease these, but there is a problem. We need to delete this value, so we can use easily a delete geometry here, but this deletes all the point, but we want to delete only the edges. And what edges? So we can use an index, and when the index is greater than 0, we can test it, we can check and link to the selection. We can see this behavior, so we can increase these, and voila. If the index of the edges is greater than 1, we have to delete these. Now we can adjust this value, linking the clip width to this size y. Correct? Not exactly, because we need to multiply this width, that is distance from this point and this point, by 2 to get the entire length. So we can shift this value, link the clip here, and use this for the size y, and this is the final result. Now we can select all these nodes, Ctrl J, F2, middle, clip part. Now that we have all this geometry in one piece, we need to merge the vertices of this separated island of these meshes. We need to use a merge by distance here, but before this we need to convert this curve into a mesh. So curve to mesh here without a profile curve, but we have a problem because the grid is already a mesh, but these curves, they are not a mesh. So we need to use this curve mesh, alt click and drag to move the node here. We need to convert this curve before the join geometry. We can use another curve to mesh here for the right part, drag into the section to include this into the section. Now we have a correct join geometry and merge by distance with 3 meshes and not 2 curves and 1 mesh. Now that we have a merge by distance, we can easily extrude the mesh. It's not correct, because for the extrude mesh node we need to have a face, so we need to fill the curve, but for filling a curve we need to convert the mesh to curve here. Okay, so after a merge by distance with a mesh, we need to convert this mesh into the curve, fill the curve with a face, shift Z to see the facing, the face, shift alt and click to see the only one face, and then extrude this with an offset scale. Now we have a problem. If I show the face orientation, we can see we have this bad result. So we need to flip this face, because if I click Shift Alt and click, we have here the normal of the face, and if we extrude this mesh, we need to flip this face and merge with this extruded result. So we need to flip the face, what face? This face before extruding, and merge together with the Shift, Ctrl, right button and drag. And this is the final result. Blue color everywhere, so the normal go outside the mesh. But this join geometry doesn't merge the vertices between these extruded faces and this flip face. We need again a merge by distance node to decrease the number of vertices. So if I mute with M this node, you can see these vertices go up. Okay, so I unmute these and we have only 64 vertices. We can hide the face orientation. Now we need to adjust two values. One is the offset scaling that we can export in our group input. So we can export these and we can rename it in clip height from 0. Remember to deselect this individual extrude for security. And now we want to transform this mesh on the z-axis going down to have a central origin of this shape. It's easy. You can easily offset this in the z-axis with a combine xyz with a transform node here. Link this to the translation, and we want to transform the z-axis by the height divide by 2. Not 2 but -2, because we want to add in the translation a value that let us to move this shape down. So we can link here, and this is the result. So I can adjust this height as I want and clip as I want. The radius is a relationship with the radius of our wires, and now we can select all these nodes, Ctrl J, F2, clip, merge. You can decrease 10 times this distance for security to avoid the strange behavior of the shape of the entire clip, because this is a very small piece of shape. Now we have to add a smooth effect to this mesh. So if I right button and shade smooth, we can enable the auto smooth, but you can see anything. Okay, and so the perfect method I think is this. So you can learn this little trick to get a correct result. You can set smooth to this geometry, but look the effect of this smoothness. It's not a good result even if I have the auto smooth selected. So how can fix this behavior? So I discovered this on the internet, and you have to join the original geometry of your mesh and then your new geometry, but keep in mind the order of these. So the auto smooth feature is applied on the original geometry and then is applied on all the geometry added to this original geometry. So Shift, Alt and click, you can see the original plane and our object with a correct auto smooth of 30 degrees. If I invert this order, so I drag this line before the original geometry, you have not the correct effect, because the auto smooth is applied from the original to all the next geometry added to it. So we need to link these in the correct order, but this is a bad result because we have the original plane. So we need to delete the geometry, the original geometry, but not all the points, because we lost the entire effect, because the auto smooth hasn't any points to be applied. So we need to use an index that is not equal to 0. So we leave only the first vertex of the original plane. You can see it because it is only 1 point, and link this result to the selection. And now we have only one vertex somewhere and the new geometry we want to see. Now that you know this little trick, you can use this technique whatever you want, getting the correct auto smooth of your new shape. You can select these nodes, Ctrl J, F2, auto smooth. Now that we have the clip, we need to instance this clip to our entire result. So to do this, we need a new horizontal curve line to instance this piece. So we can join for a moment these two nodes to see they together. We can add a curve line with a combine XYZ, set the end, add a group input. We can use the with the Y axis, resample the curve. As before, we have to use the length value, and we can use an instance on point, the clip that we have here. We can select these nodes. We can link these to the join value and Ctrl right button drag to delete this link. Now, for the first part, we need to translate these pieces a little bit to move it here in this point. So we know that here is one big radius and this is one small radius. This is the amplitude and this is the Y radius. So before instancing, we can use a transform node. We can use a combine XYZ here, link these to the translation and use what? The amplitude, adding the radius of our wire and use it to the Y, and this is perfectly aligned in this point. Now we need to adjust the number of points on this curve, so the length here by a value. So we know this, we have here one piece and we want the next piece here. So to do this, we need to know that we have here the axis of our shapes. So we know that we have one big, one big, one big, and one big. So 4 big amplitude plus what? A small, a double small, and another small radius of the wire. So 4 small radius of the wire. So we can easily get the amplitude, multiply by 4, get the radius, multiply by 4, add together and use it for the length of the resample curve. But we always have the issue described before, so we need to snap this end of the curve line in relationship with the frequency to avoid this bad result of this position. So we can easily use this with snap with what? The result of this add and use it as the Y value, and tada! This is the correct position. Collapse some nodes, move them in a correct position. We can select all these nodes, Ctrl J, F2, mono, line, clips. Now that we have these first instances, we can create the vertical instances. So we can use this entire group to instance here, here, and here. So again, we can use curve line, resample it as before. We can use a group input, an instance on point, link these and use this entire group to this instance on point. We can delete this link and use this new result to the join node. Now we need to use a combine XYZ, but as before we need to snap the height by the division between 1 and the frequency to get the current increment of this snapping value, to use it in the x-axis and link this to the end to avoid the bad behavior described before. At the same time, we need to use this 1 divided by frequency for not the count but the length of this resample curve, and this is the result. If you follow this tutorial from the start, you can easily reuse this technique because you know what's going on while creating this middle section of this entire environment. We can select all these nodes, Ctrl J, F2, vertical, clip, instances, no offset. Why no offset? Because now we are going to instance this group with a shifting in this direction to move in this position, deleting the last piece of our clips. So we can reuse this curve, this horizontal curve, deleting the last point and shift the entire curve here to instantiate the single clip that we made before. So to do this, we need to link this to a delete geometry, because we want all points minus the last. So you can use the end point selection, and we want to delete only from the end of the curve exactly one point. Here you can select this instance on point. On this point we want to instance our clip. This is the auto smooth of the our clip, and we can use this to instance on this new instance on point node. Shift Alt and click to see the result. This is the entire group. This is the group without the last point. And now we need to instance on a shifted line the entire new group. So what do we know about this geometry? We know this. Shift Z to see the wireframe layout, and we know this. We want to shift this point here. So we know that we have here double big value, so double the amplitude, and we have a small radius here and small radius here. This is for the width value, so the y-axis. So we can start with the y-axis. We need to add a group input. We can shift a little bit these nodes. Okay, we can start to instance on point, where on a curve that is similar to the original curve of the wire instancing. So we need to use a curve line again, resample, link, but we know that we need to have a vertical line with a point here, on which we want to instantiate the entire group of 4 clip, in this case, here, and so on. So we need a vertical line shifted by these values. So we need to adjust both of these values, the start and the end of the curve line. So we can start to create the vertical line and shift it to the y-axis. So we can use a combine XYZ, link these to the start, another combine XYZ, link these to the end. We can set this one, for example. Now we have a line here. You can see it because we have no geometry output linked, but we have a line here. And described by before, we have to multiply the amplitude by 2, the radius of the wire multiplied by 2, add this together and use it for the y of the start and y of the end of the curve, because we want not only the first point, but the first and the end point shifted to the y-axis. Now we need to resample by a length, and described by before, we have to snap the value of the height. So we can link the height to a snap node and use again a math operation that divide 1 by the frequency and use it to the increment of the snapping, using this for the length. And if I join this output to my entire join result, Shift Alt and click, we can see anything because we haven't set the instance attribute on the instance on point. So if I link this new group, we have this group shifted in this point. This is correct, but we want to move this new group here. So we want to move the entire curve along the z-axis before the instancing. So we need to use a set position here. Sorry, I set the snapping output to the length is not correct. I need to use the 1 divided by the frequency here to the length. We have this Shift Z to see the result, this behavior, but is wrong because we need to adjust the z-axis of these new groups using this snapping as the z-axis for the end of the curve line. So now we have the line here with these new groups, but we have to offset these to the z-axis here. And what is this distance? So the distance is this 1 divided by the frequency, that is this distance, because we have 3.4, we can set this like 3, and you can see 1 piece, 2 pieces, 3 pieces. So we want this length divided by 2. So 1 divided by the frequency, divide by 2. So we can shift these, divide by 2, and use these for the length, and this divide by 2 with a combine XYZ with the Z value, link it to the offset, and voila, we have the correct position of these new groups of these clips. But we have a problem. We need to delete the last point of the new vertical line, avoiding this new group. So before the set position, we can use a delete geometry to delete not all the points. We can use the end point selection. We want to delete only the last point. And voila, we can use this to make better the layout. Now that we have this entire section, we can select all these nodes, Ctrl J, F2, and rename it in vertical clip instances with offset. Now that we have these, we can use a little step with these wires. So one wire is not a good result, so we can increase the beauty of these wires using not one circle profile but two circle profile tilting while passing through these clips. So to do this, we need to delete these two nodes in the all instance curve. You remember what I described before, so we can click Ctrl X and Ctrl X, and now we can create a more complex shape. We can use again the group input. We can use a circle curve mesh. So remember that we had a single wire here with a single radius. This is the radius. I paint these with a big scale to better understand what this means. And we want not one wire, but we want two circle line, and use the entire radius divide by 2 to get the single radius of the single circle line. To do this, I need to use the radius, the original radius divide by 2, use it for the new circle. We need to transform this shape, so if I click Shift Alt and click, we can see it. I delete the annotation, select the circle, focus on it. We have to translate this by the radius divided by 2 itself. So we can use a combine XYZ here, and we have to multiply this value by -1 to have a negative number, because we want to move this on the Y axis but in a negative direction. And Shift D, we want to link the same curve circle and move it on the Y axis with a positive Y value. Shift Ctrl right button drag to join together, and now we can use this for a profile of our mesh. So we can use a curve to mesh here. We can link this node here, use this join geometry to have the profile curve, fill caps, and link these to the join final node. Delete this link, click, and this is the result. And you can see the correct entire radius of this shape. Now we can add a set tilt here between the line and the curve to mesh node. So if I increase this tilting, we have the result we want, but we need to create a tilting using the spline parameter. So we can use the factor that goes from 0 to 1 for the entire length of the curve. We could multiply this by the new value from the group input, so we can export this as the tilt rounds from 0, use it for the tilt, but keep in mind that we have here degrees. But if you link this node to this attribute, you are not speaking the degrees language, but the radians language. So one round here is equal to radians pi multiplied by 2. So we need to multiply this value by pi multiplied by 2 and use this for the tilting. So if I have 0 here, we have 0, and now Shift Z to see the wireframe. If I increase these, you can see the correct one complete round, one entire round here with one value. So one value is to multiply by radians. So set this to 0 for a moment, Shift Z to see the mesh, geometry. Now you can see a little issue, so if I set this to 10 and decrease the height, you can see the tilting changes. So we have to proportionally change the tilt around with the snapping of the height. So we need to add a snapping described before. For the snap here, one math node to divide 1 by the frequency, link this to the increment snapping, and if we increase the height we want more tilting because the length is bigger than before. This needs to get always the correct tilting effect for the entire length of the curve. Now we can use this snapping value to multiply node, link the tilt rounds here, and then use this with the multiply node with the factor attribute. Now if I increase the height, you can see the tilt is still the same and you can't lose the correct tilting value you want for the final result. You can collapse some nodes. Now we can select all these nodes without this section, Ctrl J, F2, curve profile, G to move. Now we can set the material, set material. If you want to set a different material for the clips and for the wires, you can easily set material here for the wires, add a join geometry here and link this value here. So we have here all the clips, and so we can do it for this tutorial. We can use the Alt and drag button to move this here, Shift D and link this here. So we can create double material clip. We can set this with a dark gray with a high number of roughness. Select these here and another material, wires that are metallic 0.05, and use it as the material of the wires. Now if I turn on the preview material, you can see the different material of the wires and the clips. Now if I go in the layout viewport, select the geometry, focus on it, we can play with the height, we can increase or decrease the frequency that we want on our geometry, we can increase the amplitude, we can increase the radius of our geometry, and you can see the clip changes in relationship with this radius. We can control the height and the width of this clip, and we can increase or decrease the tilt attribute of our wires. Let's create a better material for the clipping. Go to shading and select the clip material, check the EV render engine, go to film, make it transparent, color management, not filmic but standard for this tutorial. Click here to see the final result of the image. Click the word properties, set the color and environment texture, open the image, select the HDR you want, set 3 for the strength so we can see a better strength of this environment image. And now we can easily add a noise texture, increase a little bit, use a coordinates mapping, or you can easily select the noise texture, Ctrl T to add them automatically, link the object to the mapping, so we can isolate the selection with the Shift Ctrl click, but you can see the clip has the same mapping, so we can set a random noise. So to do this, we can adjust this location with the object info node, and we can see Shift Ctrl click. If we go in the random, you can see we can get a value from 0 to 1 for each clip, and we can use these with a multiply to have more distance between the position of the noise node from each clip. We can multiply these by 100 and link these to the location vector of the point, and you can see if I isolate the selection to the noise, we have a different pattern of the location of this noise texture. Now we can use these for the roughness, but we can use a color ramp to make this a little complex, we can set a dark green, green blue value. Okay, perfect. More dark. Okay, and we can use Shift Control click to isolate the result. I set the wrong value of the color. Control C on this color, Control V to this. This we don't care of this attribute because we have no subsurface scattering, and we can use this color map to get a better result of the roughness, and we can increase this black to dark gray to never get a pure clean plastic or similar material effect. And now we can use a map range, use a Shift D duplication of this noise, increase a little bit, link the same vector to get a random pattern of each clip, link this value to this mapping, and link this result to the emission strength if you want to use the same color of the base in the emission, so we can see better with a height values. We can multiply these with a high number to get a better strength of this emission value, and adjust the from min value to decrease the map of the noise emission to this clipping, and you can have this weird effect. For example, this is the final result of this tutorial. Thank you guys for watching this video. I hope you like it. I remember to you that you can download this project from my Gumroad page. If you like what I'm doing, please subscribe to my channel, and if you have subscribed, make sure to check the bell icon to get all the notification of new posted videos, and see you in the 6th type. Bye.